Hello students, good morning. How are you all? Students, today we are going to start a data structure subject by using Python. Okay, so, in this subject, we will cover the syllabus for this, talk about syllabus. First discuss student OOP concept, object oriented programming concept. Okay, sir, in this topic we will discuss object and classes. Right. And after this we'll discuss linked list student. And after linked list we'll discuss stack. And fourth is queue data structure. And fifth is tree and binary heap. Okay. And six is hashing. Okay, student. Now, student, what is data structure? What is data structure, student? Let's understand two scenarios, student. This is first scenario. This is your room, right? This is your room, and you put all household items. You put all household item randomly, right? Household item, just like if we talk about you are students, if you talk about your books, your clothes, right, your utensils, right? So this is disorganized room. This is first scenario, right? And here you dump all household items. If you are a student, then we can say your books, your clothes like shirt, t-shirt, pant, jeans, etc., and burton, right, utensils. Okay, you put dump all randomly in this room. So this is disorganized room, right? And another scenario, now the second scenario, here you arrange all things in proper manner. This is organized room, right? You arrange all things in proper manner, like this is all your utensils, right? Okay, kitchen racks, and this is your books rack. Okay, your books, like if I talk about Python books, DS books, Algo book, right? This individual rack. And this is your wardrobe, right? Your clothes arrange here, like shirt, t-shirt, etc. So this is organized room. Which one is better things, student? Yes. Which one is better, first or second? Yes, student. I'm waiting for your reply. Which one is a better thing? Student, wait just for 1 minute. Wait for 1 minute, 1 or 2 minutes. Okay, student. Sorry for interrupt. So second thing is better, because this is organized room. If I talk about time complexity, student, if I talk about time and time for here in this scenario, if I talk about a space and space here, student. So which scenario take more time? Which scenario take less time, student? Yes, good morning all of you. Yes, आपकी चैट मुझे नहीं दिख रही थी, अब दिखने लगी है. Yes, which one is better thing, student? Second scenario or first scenario? Second is good thing, right? So because this is organized room, so that's the data structure, student. So data structure is nothing. So here this is a data structure. Sir, what is data structure, student? What is data structure? Dear student, data structure is a way of organizing and storing data in computer so that it can be accessed and used efficiently. Okay. Okay, right. So time, if I talk about time complexity, so time complexity of this is less as compared to time of this one. If you access any book or any cloth like shirt, t-shirt, easily you can access, right? Student, within right, with less time. Here all item dumps, so it take a lot of time, student. Similarly, you are properly systematically arranged, so you can arrange more items here in this. So if I talk about just a minute, bache, I think this one, it take more time. This one, room one take more time, and similarly, this take, sir, more space. So what are the use of computer, student? Why we are learning computer science, right? we are learning computer science to minimize time and space complexity, right, student? So this is better thing, student. In this case, it will take less time as compared to this first, right? This take less space as compared to this. You can organize more items here. No, we cannot say let space. You can organize more items here, right, student? Yes, student, आपकी chat नहीं दिख रही थी मुझे. Okay. So data structure is a way of organizing and storing data in computer so that it can be accessed and used efficiently, बच्चे. Understood? So this one is better thing. This one is better thing, right? So, sir, is data structure is a container? Yes, this is the one thing. Data structure is a container. Basically, data structure deal with two things, student. So, data structure is a way of organizing and storing data in computer so that it can be accessed and used efficiently. And data structure basically mainly deal with two things, student. Data structure mainly deal with two things. First one is how efficiently data can be organized and stored in computer memory like RAM, cache, secondary memory. If we talk about uh, sir, secondary memory for large data, then we will use sir, what is sir, B tree and B plus tree, right? This is used in indexing. Okay. Second thing, sir, how efficiently data can be retrieved and manipulated. How efficiently data can be retrieved and manipulated. So data structure mainly deal with two things. Okay. Organized data plus operations. Basically, search, insert, and delete take less time, student, right? So optimize. It will be optimize. It must be optimized. Okay. Less time. So this is data structure, student. So let first discuss data structure, sir. Linked list. Okay. In the linked list, first discuss bache what's our OOP concept. OOP means object oriented programming, right? Object and class concept. And second, linked list node class. In today class, we will discuss this one, student. The linked list and node class, how we can create linked list and how we can create node class, right? And dynamic memory allocation and deallocation, right? In कैसे होगा Python में? Single linked list creation and operation on single linked list. Okay, right? इतना ही हो पाएगा, I think. So this will cover in the next class, right? So let's start first object-oriented programming concept, student. Object-oriented programming. What is object-oriented programming concept, student? Object-oriented programming a paradigm that uses object and classes to design and structure code. Python support object-oriented programming, allowing developer to model a real-world entity efficiently. Okay, you feel just like a real world with the help of object-oriented programming, right, student? So, key concept of object-oriented programming in Python. What is the key concept of first one is class, class and object, student. And if I talk about second is object. Sir, what is class, student? What is class? Class a blueprint for creating object बच्चे. Class a blueprint for creating object. For creating a object. Class is nothing, it is a blueprint for creating an object. And what is object? An instance of a class. Object is an instance of a class. What is class, student? What is the significance of class? Actually, class, it is a blueprint of object, blueprint of creating object, bache. Right? Basically, class is a user-defined data structure that define attributes, any data, and methods, function to operate on that data. So class, what is class, student? Class, it is a blueprint for creating objects. Okay. A class is a user-defined data structure bache, that define attributes, data, and methods, function to operate on that data. Okay. And what is object? Object an instance of a class. It is an instance of a class, bache. Right? Object is an instance of a class, meaning it represents a specific entity created from the class blueprint. Okay. Sir, how we can create class and how we can create object, bache? So for creating a class, you have to use this class keyword. Right here class keyword, student, one space, right here class name and colon. First one right here class keyword space class name and colon. Right? What is this, student? Inside this class, this is a constructor, init constructor. When you create object, this constructor automatically called, and the properties or attribute of this class initialize, student. Okay. Object, property or attribute of object is initialized. So here this def underscore underscore this like this underscore underscore init underscore underscore, this line, this one. This line, the meaning of this line is what will here this init is a constructor. So when this constructor call, student, this constructor call, when you create object of that class, then this constructor automatically called, and the properties or attribute of object is initialized. This is the functionality of this. Okay. So basically this class, the class student, this class is doing what? A class, it is a user defined data structure, bache, that define attributes. It means data, that define means attributes. These are the attributes or data, and methods. This is the method, student, this is the method, and method, any function to operate on that data. So class, it is a blueprint for creating an object, and it is a user defined data structure that define attributes, these attributes, right? Attributes or data, and method, function to operate on that data. This is a method. Okay. So my dear student, first understand this. Here init, it what, sir? This init is a constructor. This is a constructor. What is the role of this? We'll discuss shortly. Everything, student. Here, sir, this self is a parameter, first parameter. Bache, this is the first parameter, a reference of current instance. Reference of current instance. And it must be a first parameter. It must be what, sir? This is first parameter. It must be first parameter. You can write here any name. Not, it is not compulsory कि you can write here self also. No, you can write x, y, z, w, right? Sonu, Monu, Golu, jo bhi, whatever you need, right? But the condition is it must be a first parameter. What is the indication of this? The meaning, significance of this? It is a reference of current instance, or this is the first parameter, right? And sir, you can take any name. Okay. Name and age, these are the attribute or variable, or we can say properties of object. Attributes, or we can say variable, or we can say properties of object. Properties of object. Okay. Sir, what is happening here is, sir, what is you're doing here? This is the initialization of d raised to initialization of attribute or variable. Initialization of attributes or variable. This is the initialization here. And this is method or function. This display, this is method or function. We can, and the display, this is method, or we can say in function. In C programming, we are saying member function and member variable. So these are the member variable at like name and age, in right, and these are the methods, or we can say function. Sir, how we can create object, student? For creating a object, write here this class name. Sir, write here this class name, bache, this class name. Sir, how we can create object, bache? Sir, before creating object, sir, is there any memory allocated for this class, student? Yes, student. Class, it is a blueprint. Just it is a structure blueprint. No memory allocated, right, for class. जब तक आप ऑब्जेक्ट नहीं बनाएंगे उसका, अंडरस्टूड? जब तक आप इंस्टेंस नहीं बनाएंगे, इसके लिए मेमोरी एलोकेट नहीं होगी बच्चे. सो दिस इज द ब्लूप्रिंट और स्ट्रक्चर की, राइट? ओके. Structure of class, or it is a blueprint, no memory allocated. When you create object of this class, then memory allocated, and right, memory allocated for each member variable. Okay, or attributes. Sir, how we can create object, bache? For creating an object, write here this class name. So write here what? Sir, this is a class name, and pass here attributes. Sir, attributes is what? Sir, name and age. Pass two parameters. This is the instance of the current. This is the reference, bache. Nothing. No need to pass this. Right here, this what? Sir, name and age. When you create object, you are creating object s1 equals to student class name, and here attribute of this class or property. Then object one instance or object is created and memory allocated, right? And automatically this init constructor called and memory initialize also, right? So if you write this line, then what will happen, student? If you write this line, student alias 20, then what will happen? You are creating, basically you are creating object s1 instance. Then what will happen, student? This memory is allocated in this way. Okay, the memory is allocated student this class, and for instance s1. Okay, and this class contain two member variable, name and age. Name and age. Okay, when you create this line, then and s1 is pointing to this one, student. S1 is pointing to this memory, right? S1 is the object, this pointing to name of this reference of this memory, right, student? And self, self is what? It is the reference of current instance, current instant, it is the reference of current instance, right? And when you write this line, then init constructor automatically called, bache, when you write this line, then automatically what called, sir? Automatically this init constructor call. Automatically init constructor called and initialize attribute. Is it visible, bache? What will happen when you create object of this class, then automatically init constructor called and initialize attributes. Sir, kaise? Sir, you are writing this alias, so name is initialized to this alias, and second age is 20. Okay, and S1 object, this is pointing to this one, and self is a reference of current instance. Okay, one more concept, student. Inside the class, if you want to access this attribute, then you have to use what, sir? Self parameter, right? This self parameter. Okay, because self is pointing to current instant. If you self is pointing to current instance, so inside this class, if you want to access this attribute or property of object, then you have to use this with the help of this self parameter. Understood? This one, right? Inside the class, either in here this constructor or in method also, you are accessing name, then self dot method, you are writing what's a self dot method, self dot age. So inside the class, you have to use what's a self parameter. This is the first parameter. You can take any name, x, y, z or w, jo bhi naam hai, but this is first parameter, and the more realistic name is self. Self means, right? So inside the class, if you want to access attribute, then you have to use what's a self parameter. And outside the class, you can use object name. Suppose I want to access s1 dot name, s1 dot name, then definitely it print name. What is name? Name is alias. Chalega bache. Okay, now, sir, here I am calling this is a creating object, and this one is what, sir? This one is what, sir? I want to call method display. Here I am calling method display. Then what is the output of this one, student? Yes, s1 dot display, s1 dot display, the output of this one, sir, name, self dot name is what, sir? Alias, right? And age, one space, age is what, sir? 20. So this is the output, student. Is it clear to everybody? Again chat lock हो गया क्या? Okay, so this is fundamental, student. Fine. Now, so class, it is a blueprint, student. So here I want to display the 𝐂𝐸𝐷A student scorecard, 𝐂𝐸𝐷A 2026 student scorecard. Then what is blueprint for 𝐂𝐸𝐷A scorecard, student? So this is I am creating a class for 𝐂𝐸𝐷A student, class and class name 𝐂𝐸𝐷A student, and define this init underscore underscore init constructor and self first parameter, राइट नेम. सर स्कोर कार्ड में क्या क्या होगा बच्चे? सर नेम, रोल नंबर, ब्रांच, ईयर, स्कोर, राइट? सो इट इज ए ब्लूप्रिंट कि स्कोर कार्ड में क्या क्या होगा. ओके, self.name equals to name, and this is the initialization, right? Initialization of attribute. When you create object of object of this class, then automatically this init constructor call and all the attribute initialize. All right, student. Okay, this is the member method. This is the method of this class. The method ke through you can display scorecard, student. Print name self.name. Here I am using f string. Okay. So this is creating of object. How we can create object? Right here class name get da student class name, and attributes. First attribute sir kya tha? Sir name. So this is Amit Kumar. Second is roll number. So roll number is this one. And branch is DS and AI, data science and AI. Year is 2026 and score is 99.62. Right? Let's suppose. And I am creating another object, student 2. How we can create? Sir, right here class name, bache. Right here class name, get DA student, and the name is Priya, and roll number DA202 this one, and DS and AI, DS and branch 2026 98.79 percentile. All right, student. Fine. Now displaying student result. How we can display? So just call this method student display method. Student object this student 1 dot display, then this entire scorecard is display. Student 2 dot display, then entire scorecard is display. Okay. So output display look like RAM, roll number, branch, year, gate score, gate score. Okay. And after this, sir, 30 this 30 times, right, student? So this is layout of a scorecard. Okay. So here you are creating class blueprint, and inside this class you are initializing the attribute or this method for displaying, right, uh, object properties. Now here I'm just creating object. So first you create object, then memory allocated for this student 1, memory allocated for student 1 ke liye this memory allocated, Amit Kumar memory allocated, and you are getting second instance of the class, then against student 2 ke liye memory allocated, right. I want to display student 1 scorecard, student 2 display card, then you have to use student 1 dot display, student 2 dot display. Okay. So when you create object of first class, then automatically this init constructor call and the attribute initialize. जो भी आप यहाँ से देंगे वो initialize हो जाएगा. Fine. अगर आप यहाँ से display करेंगे तो कैसा output आएगा बताओ. So first name is what you are passing, student 1 Amit Kumar. This name is student. Name is Amit Kumar. Roll number is what, sir? DA. DS and AI. Right. And year 2026. Scorecard 99.62. This is first student display, right? This result. Second time you are you want to display second student information, then again you are calling for student 2 also. Student 2 के लिए call किया, then output is what, sir? So first this is Priya, DA, again 30 टाइम इस तरह से 30 टाइम डिस्प्ले हो जाएगा, right? So this is class and how we can display attribute. Okay. So basically class in Python, what is class in Python बच्चे? Class is a user defined data structure that define attribute, data and method function to operate on that data. Okay. Okay, very good. So how we can create class बच्चे? Class, just write here class and class name. This car is what, sir? This is a class name, and here this init, this is a constructor बच्चे. First this is a constructor, define underscore underscore init. This is a constructor. Okay. What is this constructor doing? Constructor init to initialize object properties, to initialize this object property. This is right. When this will call, sir, when you create object of this class, then automatically this init constructor call, or ये सारे initialize हो जाएंगे, right? Here method to display car. Here I'm just writing this method, sir, display self and print sir all sir brand model all attribute. Okay, student. So how we can create object? Car1, I am creating object of this class first car के लिए. Car1. So right here class name बच्चे. What is the class name? Sir, class name is car बच्चे. Class name is car, and the first one is brand is let I write here Toyota. Brand, I am first brand I am writing here Toyota, and model Camry, right? And year, sir, 2022. Then what will happen if you write this line? Then what will happen in student? Brand model year. Okay. Brand memory allocate हो जाएगा for first object के लिए. Carbon object. This carbon is the reference of first object. When you create this object, how we can create objects, sir? Right here class name, this class name and this variable name, right? Brand is you want to pass Toyota, Camry and 2022. When you create this object, then automatically init constructor call bache. Automatically this init constructor call and this memory is initialized. Sir, brand is initialized to Toyota, model is initialized to Camry and year is initialized to 2022 automatically bache. And car1 is pointing to this one. Car1, this is the reference pointing to this one, right? Okay. Now what about self? Self is an instance of current instance. So here self is pointing to instance of current instance. Okay. So when you create object of this class, then this displays to one. Similarly, sir, I want to create another object. So again, write here class name and pass brand, model and year. Pass attribute here. Honda, sir, brand is Honda, model is Civic, and year is 2021. Okay. Then what will happen is, student, sir, one more object के लिए memory allocate हुआ. This is another object. Sir, brand, model, year. Sir, brand is what, sir? Honda. When you create this line, then automatically, sir, this init constructor call and these all attribute memory जो है वो initialize हो जाएगी. Brand किससे? Honda से. Brand से pass हुआ. Model, sir, Civic and year is 2021. Right. And car2, this is pointing to this one. And now self is pointing to, if I talk about this one, self is pointing to this one. Okay, this memory is allocated. Now I want to print carbon dot brand student. Then what it will print? I want to print carbon dot sir brand. What it print student? Tell me. Carbon dot brand. What it print student? Sir, carbon dot brand equals to what, sir? Toyota. This is Toyota. Similarly, if I talk about car2 dot model, what it print student? If I talk about car2 dot model, car2, this car2 model is what, sir? This is Civic. So in this way, you can display each member variable, or you want to use this display method, you can display entire this information of car1 and car2. Okay. So let I write car1 dot display. Then what is the output? How we can call this method student? Just write here object attribute car1 dot display. And similarly for car2 dot display. What is the output of this one student? Yes, carbon dot display and car2 dot display. So in this way, f string, in this way output display bache. Carbon dot display. If you so it print what, sir? Car, this car, colon. Here you are talking about what, sir? Carbon. So carbon detail. Go to carbon detail and it print what, sir? Carbon self dot brand. Sir, carbon self dot brand is what, sir? Toyota. And sir, self dot model. What is this model? Camry. Right? And year 2022. So this is the output student. Similarly, if you call for car2, right, then self is pointing to this. You are talking about this one, car2 dot display. So car2 dot display, the output of this one, sir, car. First printing, you are printing what, sir? Brand. Brand is what, sir? Honda. And self dot model Civic. And year is 2021. So this is the output. So in this way, you can create class, you can create object, you can display attribute of object, right? Is it clear, student? If you want to use attribute inside the class, then use self keyword, right? Self, this first, whatever you write here, use this self. Outside the class, you can use this object reference, sir, carbon car2. Now student, so object is an instance of class, meaning it represents a specific entity created from the class blueprint. Okay, we have already discussed object here. We have already discussed this object here, student. So an object is an instance of a class, meaning it represents a specific entity created from the class object blueprints. Already we have discussed in this slide. Okay. Now come to constructor. What is constructor, student? Basically this constructor like this one, underscore init, like this one, student. Okay. So constructor in Python kya hai? What is the use of this one, student? A constructor in Python is a special method that is automatically called when an object of a class is created. Okay, already we have discussed this thing. It is used to initialize the attribute of class. What is the use of this init constructor? Sir, it is used to initialize the attribute of a class. Okay. How we can use, student? So write here class name. First write this things, student. Define constructor, right? Def underscore init self parameters here, parameters. Okay, and here you can initialize all attributes, right, student? So the constructor method is always named with underscore underscore init. Second, it takes self as the first parameter. It takes self as the first parameter, which refer to instance of the class. Okay. Third point, additionally parameter can be passed to set initial value. Additional parameter you can pass here to set the initial value. Okay. Understood? So this is the use of init constructor. Now example of constructor. क्या होगा बच्चे? What is happening here, student? What we are doing here? We are creating object. So this is a class person, and this is a init constructor. Here we are doing what's our initialization? Initializing name and age. Name and age, yes, initializing name and age, student. Initializing name and age. Okay. And this is the method display attribute. And what is here? We are creating object, right? Creating object. In this line, we are creating what, sir? Creating object. How we can create object? Right here, this class name and the attribute. Okay. We are creating object. In this line, p1.display, p2.display, calling method to display detail, बच्चे. Calling method to display details, not result, to display details. Okay. So चलिए first object create करिए. When you create first object, then what will happen, student? If you create this first object, then memory allocated for this. And these two things, what's her name? And sir is. Okay. And P1 is pointing to this one. Right? When you create this object, then automatically this init constructor call and these attribute initialize. Name is initialized to name. You are passing here name is what, sir? Alice. And age is initialized to 25. And self is also pointing to this one. All right. This is the meaning of this one. All right. What about second? In second, same thing. It's student. If you create object of this second class, right here class name and attributes. So and P2 this is pointing to this one, and name is initialized to name. You are passing name what, sir? Sir Bob. And age is what, sir? 30. And self is pointing to this one. Okay. If you call p1.display method, then what is the output of this one, student? p1.display and p2.display. If you display, you are displaying this method. So p1.display result is what, sir? Name. Sir, p1.display, what is the output? Name equals to self.name. Self.name is what, sir? Alice. Okay. And age 25. p2.display. What is p2.display? So p2.display output. Sir, name. What is p2 name? Sir, Bob. And display age is 30. So this is the output. Okay. So in this way, basically in this way, you can use class, you can create class, you can create object, right? You can access attribute of a class, right? So, and this is init constructor, everything we have discussed. Okay, student? So init is a method, initialize name and age when an object is created. Second, P1 and P2 are instance of person and their attributes are set when they are initialized, right? Is it clear, student? Yes, Sidhu, Uddhav, rest of all candidate, is it clear to everybody? Yes, bhai, bolo, say something. Now next, this is the key concept about classes, object, constructor, method and attribute. Okay. So my dear student, class means a template or blueprint for creating object. No memory allocated. जब तक आप ऑब्जेक्ट नहीं बनाएंगे इसके लिए मेमोरी एलोकेट नहीं होगा. फाइन. सेकेंड, ऑब्जेक्ट क्या होता है सर? एन इंस्टेंस ऑफ ए क्लास रिप्रेजेंटिंग रियल वर्ल्ड एंटिटी. राइट. ओके, वेरी गुड, वेरी गुड. क्लियर हो गया, वेरी गुड. कंस्ट्रक्टर, दिस इनिट कंस्ट्रक्टर क्या होता है? ए स्पेशल मेथड टू इनिशियलाइज ऑब्जेक्ट प्रॉपर्टीज. ओके. मेथड्स बच्चे क्या है? इट इज अ फंक्शन डिफाइंड इनसाइड ए क्लास टू परफॉर्म एक्शन ऑन ऑब्जेक्ट. ओके. नाउ एट्रीब्यूट्स क्या होते हैं? वेरिएबल्स एसोसिएटेड विद एन ऑब्जेक्ट. So this is the key concept. All right. Now come to first data structure, linked list बच्चे. इसको बाद में करते हैं. Now what is linked list in Python? Linked list is a data structure not only in Python, and we can say in C programming also. It is a data structure, student. What is linked list, student? Linked list, it is a non-linear data structure, you know. And how information is stored in the linked list? In the form of node, student, right? Linked list, it is a linear data structure. Yes, it is a linear data structure. It memory allocated contiguously? No, memory allocated not contiguously, right? In linked list, information is stored in the form of node, right? Node. Every node contain what's are two parts. If we talk about single linked list, data part and next part. Data part is store the actual data, and next part is store what's are the next node address. Okay. All right, student. So linked list, it is a data structure in which element node are stored in linear sequence, but are not stored in contiguous memory location. Yes, sir, correct. Right. And each node contain what's our data, the actual value, right? A pointer, any next node that point to the next node in the list. So my dear student, in linked list mein data, how data store is to in the form of sir node, in the form of node, student. Okay. And this node, this is a data part. This is a data part, actual data or information, and this is the next part or pointer part. It store the address of next node, student. Here it is a data part. Okay. So this is node, student. Got it, student? Okay. So how information is stored? Unlike in array, linked lists do not require predefined size and allow dynamic memory allocation. This in linked list we can create, we can grow or shrink the linked list size. How? कैसे sir? देखिए, look here, student. Dear student, in array, if I talk about in array, and data is stored in the form of sir, कैसे data store होगा? Contiguous memory allocation. Suppose I want to insert like A, B, C, and D. Okay, in array. So array may information store how information. This is the base address. Let's suppose this is the base address 100, and all our character. Next is 101. Next is 102. This is 103. Okay, and these are the subscript 1, 2, 3. So information is stored in the form of in contiguous memory allocation. Right. This is a contiguous memory allocation. Right, and this is the base address. If you know the base address, you can access any element. Right, randomly you can access element, student, order of one time. Okay. In array, so this is what, sir? Let the array name is A. Okay, A0 and A1, A2, A3. You can access randomly, student. Random access. Random access, and time complexity is what, sir? Order of one constant. This is good thing, student, right? But the problem is array. This is not flexible. Suppose runtime pe I want to increase the size of array, you cannot increase. Suppose I want to decrease the size of array, you cannot decrease, right? But sometimes there is a scenario. Sometimes we need flexibility. At runtime, I want to increase the size of right linked list or decrease the size of linked list. Then you can increase or decrease in linked list, but not in array, student. This is the limitation of array. This is not flexible. Sir, what about linked list? If I talk about in linked list, student, so information is stored in the form of node. This data A, B, C, D. Let the address of this is 100, 200, 300, and 400. Okay. And here the last part contain none. So this is the linked list, single linked list. In single linked list, information is stored in the form of node, and every node contain what, sir? This is the data part and next part. Here this is the data part and next part, and data part and next part, and this is the data part and next part. Okay. So dear student, here you can access data, and for next data ke liye, you have this pointer. You can go at this side. You can access this data. For next data, and you can access this. For next data, you have a pointer. You can go in forward direction D. And after this, this is none. This is the end of linked list. It means your data is what, sir? A, B, C, D. But what is the benefit of this linked list? This is a flexible runtime pe. You can increase or decrease the size of this linked list. How, sir? Kaise? Sir, I want to increase the size of linked list. Just create student node, and let the address of this node is 500. Okay, and assign here, sir, what, sir? 500. So this one is pointing to this one, and assign here data, and this part is none. So this is data part and next part. You can increase or decrease the size of linked list. Similarly, sir, I want to delete this node B. I want to delete this B node. How we can delete, sir? How we can delete, बच्चे? You can delete, sir. कैसे? Sir, then इसके next part of this is what, sir? 300. So this is pointing to this one. Okay, and free this node, student. Free this node. So you can increase or decrease the size of linked list at runtime, right? This is the flexibility. It is just like in, if we talk about an Indian railway system, right? This is a train, student. The train bogies. These are the train bogies, bache. Understood? And this is the train system, right? Understood? So in bache, in Indian railway system, why train is just like a linked list? Tell me, anyone reply, answer? You know, not a single coach, just like two lane. Sir, in train just like a linked list, student, you can increase or decrease the size of train, student, according to your situation, right? You know, I think you have observed during winter season. During winter season, the train size is small, right? Train size is small, but during festival season, train size is increase. Train length is increase. Okay, so you can increase or decrease the size of a train in this look. Similarly, same logic apply on a linked list, student. So this is flexible. This is flexible, right, student? So types of linked list, there are three types. Single linked list, each node point to next node. We'll discuss one by one, bache. What is single linked list? We'll discuss in single linked list, double linked list, and fourth is and double linked list, circular double linked list. Okay. So how linked list work vache in Python? In Python, how linked list work, student? Let's create a simple linked list with using Python. कैसे? Sir, how linked list work? So define two terms, bache. Define a node and create the linked list. Okay. So how linked list work? For this linked list के लिए first define a node and then create the linked list, bache. How we can define node, student? Sir, node contain two part, bache. Each node contain two part, data. Each node contain two part, sir, data, the actual value, next a pointer to the next node, a pointer to the next node. Sir, what does it means? You have to create node, student, and this is data part, and here this is next part. It store the address of next node. Okay, so this is node, student. This is node. Understood, student? So first you have to create node, and second, creating the linked list. So create the linked list. Second thing is creating the linked list. Okay, creating the linked list. Sir, creating the linked list is doing what, student? In this case, I am creating this linked list, student, and this is head pointer. Okay, initially it is none. Okay, creating the linked list. Initially, first bache define node and then creating a linked list. Initially, this linked list contain what? None. And after this, sir, connect these two nodes. So connect, let the reference of this is 1000, and after this assign here 1000. So this one is pointing to this one. So there are two terms you have to define, defining a node and creating the linked list. Understood, student? Fine. So first discuss, student, node class. How we can create node, student? For node ke liye you have to create node class. For linked list ke liye you have to create linked list class, right, student? So let first discuss defining a node. Node class represent a node in the linked list. Node class represent a node in the linked list. Sir, कैसे होगा? Sir, class node, class to create a new node. Sir, node contain two part, बच्चे, data and next part. Node contain what, sir? Two part. Sir, first one is data. Node contain two part, बच्चे, data and what's the next part? So you have to create this class, node class. So right here init constructor self data. Self dot data initialize this memory initialize हो जाए and self dot next automatically none assign हो जाए. Okay. So अभी ये मेमोरी एलोकेट नहीं हुआ है बच्चे. अभी ये मेमोरी एलोकेट नहीं हुआ है, right? This is the layout blueprint. Okay. Now node 1 equals to node 10. Node 10. This is what, student? Everyone reply. Node 10 means what? बोलो भाई. Node 1 means what, Siddhu, Savira? This node 10 means what is what this line is doing, student? This is node class. Here I am writing node 10. What is the meaning of this? Creating object, student. Creating first object, node 1. Understood? I am creating first object, node 1. Understood? And the data part of this node is 10, and by default, sir, next part is what, sir? None. So when you write this line, then what will happen, student? Everyone look here. you are creating the object of this class. So automatically this init constructor called, and data part is initialized to this value, and the next part is initialized to none, right? And node 1 is pointing to this one, student, and self is also pointing to this one, if I talk about this one, right? Understood, student? Now what about in second line? Similarly, we are creating an object for second line also. We are creating object for this also, right? And data part is initialized to data. Automatically this init constructor call, and data part is initialized this 20, and the next part is initialized to, sir, this one is what, sir? None. Okay. And self and node 2, both is pointing to this one. Node 2 is pointing to this one, and self is also pointing to this one. What about in this line, student? What about in this line? इस लाइन में क्या हो रहा है, बोलो भाई. Yes. Yes, student, say something. लिखा है बच्चे नीचे, linking node 1 to node 2. Sir, node 1 का next part assign node 2. Okay, let the reference of this is 1000, and here the reference is 2000. So linking node 1 dot next equals to node 2. So node 1 dot next equals to node 2 means what, sir? Let 2000. So this is linking of 2 node. Okay. So here this is the explanation. This class represents a single node in a linked list. In it, this is the constructor method that initialize self.data, store the value of the node, self.next, pointer to the next node in the list, initially set to none. Okay. Each node hold 2 pieces of information: data, the actual value, and next, the reference to the next node in the list. Okay, already we have discussed these things. Okay, now this is node class, student. Now next, second is a linked list class. Bache. Linked list class represent the linked list. So class linked list, class for creating for linked list, this is a constructor define underscore underscore init self. Sir, there is no extra parameter, no attribute. Self dot head is initialized to none. Self dot head is initialized to none. कब sir? When you create object, then automatically ये हो जाएगा बच्चे, right? How we can create object, sir? For object के लिए you have to write what, sir? This class name, you have to write class name linked list. LL is a linked list. Then object is created, and the head part is initialized to none, student. So look here, student. So this is a class, linked list class constructor. Sir, when this constructor call, when you create object of this class. So linked list, sir, there is no attribute here. So LL equals to this constructor call. This constructor बच्चे कहाँ गया? This constructor call. Okay. And head LL equals to this object LL. LL is called, and only one part head, it is initialized to none. Head is initialized to none, right? What about in this line, student? In this line, in a single program, node 10 is doing what, sir? This is doing, it create the object of node class. So similarly, it create the object of node class. Sir, what will happen? Sir, one node is created, and the data part of this node is 10, and next part is what, sir? None. And कहाँ गया? Yes, this one. And here I am saying linked list dot head equals to what, sir? Node 10. Let the address of this is 1000. So you are passing what? So linked list dot head equals to node 10. Linked list dot head equals to node 10. It means, so this one is pointing to this one. Okay. So this line create an empty linked list. First line, this create an empty linked list. Line number 2, manually adding a node with value 10. Okay. So this is a linked list having one node. In this way, you can create linked list having one node, student. Okay. Now ll.head point to the node containing 10, making it the first node in the list, student. Okay. So this is the linked list class, and you can connect link. This is the linked list class, right, student? Okay. Now how these classes work together? If I want to work these classes work together, then what will happen, student? So what is the output of this code, student? So this line is doing what? Create an empty linked list. Create an empty linked list. Understood, student? What about in second line? Create a node with value 10. Create a node with value 10. Create another node with value 20. Create another node with value 20. Okay. And what is here happening here is, student? ll.head equals to node 1. Head now point to node 1. Head now point to node 1, student. What is happening in this line? Node 1 dot next equals to node 2. Link node 1 to node 2. Okay. So let's discuss one by one, student. When you create first line, then it create what's our empty linked list. When you create first line, head equals to none. When you create second line, then what, sir? What will happen, sir? This is data part and next part, and here this is node 1. So node 1 is pointing to this one. Okay. So this is 10, and here this is none. All right. Node 1 is pointing to this. Node 2 equals to, you are creating another node. Data in next part is 20. Here data is 20, and the automatically init constructor call होगा. ये आपका ये result हो जाएगा. Let the address of this node, let us assume कि this is 1000 and here this is 2000. Okay. ll.head equals to node 1. ll.head means this one equals to node 1. What is node 1? Sir, node 1 is 1000. So this one is pointing to this one. Sir, node 1 dot next equals to node 2. Node 1 dot next means this equals to node 2. So this is what student 2000. This one is pointing to this one. So this is the linked list, right? Linked list. This is the linked list. This linked list is created, right? Okay. So in this way, you can create linked list in Python, बच्चे, by using object and class. Okay. So ये यहाँ पे लिखा हुआ है बच्चे, सारी चीजें लिखी हुई हैं. So node class create individual node storing data and references. Next, linked list class manage the linked list keeping track of the head first node. Okay. So ये है कहानी linked list की. Now dynamic memory allocation बच्चे. Oh sorry, मैंने देख नहीं पाया. यस, पाइथन में इस तरह से अरे नहीं है, बट वी कैन मेंटेन अरे बच्चे बाय यूजिंग लिस्ट और अदर मेथड. अरे नहीं है बच्चे. मैंने आपका चैट नहीं देखा था। सिट यार, मैं पता नहीं भूल जाता हूँ। उद्धव, बिल्कुल करूँगा, मैं बिल्कुल करूँगा बच्चे। ओ, सॉरी, आई फॉरगेट अगेन, एक्चुअली अभी कुछ इस तरह का चल रहा है शेड्यूल। बच्चे, नमपाई अरे वगैरह अलग है, उस तरह का अरे जैसे सी प्रोग्रामिंग में आपने पढ़ा है वैसा नहीं है। हाँ, ये सुझाव मैं अब बिल्कुल ध्यान रखूंगा इस बात का, स्पेशली ध्यान रखूंगा। एंड एक मैसेज भी मुझे कर दिया करिए। ओके, व्हाट्सएप मैसेज। ऑल राइट। सो डायनेमिक मेमोरी एलोकेशन एंड डी एलोकेशन समरी बच्चे। एलोकेशन ऑटो हैपन ऑटोमेटिकली व्हेन क्रिएटिंग ऑब्जेक्ट। when you create object student node and list, when you create object node and list object, then automatically memory allocated. No need to write explicitly, just like a malloc, calloc, realloc, just like in C programming. No need to write this. When you create object, automatically memory allocated, right student? Now second, deallocation. Python garbage collector automatically free memory when an object has no reference. Python garbage collector automatically free memory when an object has no reference, then Python garbage collector automatically dereference or automatically deallocate memory. All right. So no need to write explicitly free this memory, just like in C programming. Understood, student? Now, bache, what is the output of this? Everyone reply answer for this question. This is a linked list. Okay. Sir, head is a variable, so which variable means inside value. So what is inside value here? 100. So it print 100. Head data. Sir, what is head data, student? What is the data of head? Sir, head it means 100. 100 data is what, sir? This is the data part. This is the data part is what, sir? 10. Head dot next. So first part, this is the data part, and second is the next part, student. So head dot next is what, sir? 200. Head dot next is 200. Similarly, is okay. Fourth line meaning is what? Suppose this condition is true, then what is the meaning of this, student? Let's suppose if this condition is true, suppose this condition is true, then what, sir? Then what is the meaning of this, student? Suppose this condition is true, then what is the meaning of this? If head equals to none, let's suppose this condition is true, then what is the meaning of this, student? Suppose this condition is true, then what, sir? Linked list is empty. If head is pointing to none, then linked list is empty. Okay. What about fifth, sir? Head dot next equals to none. Suppose this condition is also true. Then what is the meaning of this one, student? Linked list contains single node, right? Then linked list has single node. Okay. What is the output of this one, student? Yes, everyone reply. What is the output of line number this sixth? What is the output of line number 6? Yes. Yes, 𝐂𝐤𝐬𝐿. Yes, correct. What is the output of this sixth? Head dot next dot next dot next dot data. Sir, what is the meaning of head? Head contain what, sir? 100. Sir, 100 का next part is what, sir? The next part of this 100 is what, sir? Sir, 200. 200 का next part. 200 next part. Sir, what, sir? Sir, this is 300. 300 next part is what, sir? 400. 400 data part is what, sir? 400, the data part of 400 is 40. So the output of this is 40. Okay. What about seventh, student? Okay. Head means what, sir? Head means 100. 100 का next part is 200. Sir, 200 का next part is 300. 300 का next part is 400. Sir, 400 का next part is none. And none ka data, this is what error. You are referring illegal memory, right? You are referring illegal memory. So this is error, student. You are dereferencing none. So this is error. All right. Okay. Now, this type of question already asked in GATE exam, GATE CSE. Okay. In GATE CSE paper. So I converted to this question in Python. So this type of question may be asked in GATE exam, your GATE DA exam. So yes, everyone reply answer for this question. This is line number here, line number 1, line number 2, line number 3, and line number 4. उद्धव is saying E. Okay, देखते हैं. Okay. Yes, everyone answer. P equals to what, sir? Head dot next dot next dot next dot next. So directly, sir, you can check out here. Head dot next is what, sir? Head means 100. 100 dot next is 200. 200 next is what, sir? 300. 300 next is what, sir? 400. And 400 next is what, sir? 500. So this term is what, sir? 500. So basically P is set to 500 node. P is set to what, sir? This node, 500 node. So P is pointing to this node. Okay, in line number 2, in line number 2, student, head dot next is what, sir? Sir, this is 200, and 200 next is what, sir? 300. Now, sir, 300 next update हो जाए किससे? इससे. I want to update the next part of 300 via, sir, P dot next dot next. Sir, P is what, sir? 500. 500 next is what, sir? P is 500. 500 dot next is 600. And 600 next is what, sir? What is the 600 next? Sir, 700. So this line is saying, many of the students confused in this line. So what is the meaning of this line? This line is saying, I want to update the next part of 300 node via, sir, 700. Sir, update 300 next part. Sir, what is 300 next part? This one. Via what, sir? 700. So here this is 700. So this one is pointing to 700 node, right? This is a 700 number. What about in line number 3? What about in line number 3, bache? Line number 3, sir, P is 500, P dot next is 600, and 600 next is what, sir? 600 next is 700. And P dot next is 600, and 600 next is 700. And I want to update the next part of 700 via what's our head dot next? What is head dot next is 200. What is head dot next is 200, bache. So 700 का next part क्या हो जाए? Sir, 700 का next part, this is 200. So if this is 200, so this is pointing to this node. Okay. Now fourth line, student. Sir, P dot next. What is P dot next, student? 600. P dot next is 600. 600 next. 600 का next is what, sir? 700. 600 का next is this is 600, and 600 next is 700, and 700 का next is what, sir? 200. And 200 का next is what, sir? 200 का next part क्या है बच्चे? 300. And 300 next is 700. And 700 next part is again, sir, this is updated 200. 200 next part is what, sir? 300. And 300 data part, sir, data part of 300 node is what, sir? क्या है बच्चे? Sir, this is C. Okay. So output is what, sir? C, not E, bachche. C is the output. So this is C. Okay. So this part is doing this part, C. C is the output. Okay. So this is very good question. इस तरह के questions आपके गेट एग्जाम में पूछे जा सकते हैं बच्चे. अंडरस्टूड? क्लियर हुआ? Okay, no problem. Now, tell me, consider the following code definition. The node class, this is the node class, which of the below option correctly execute without error, student? Which one is correct? D part, Sidhu. Which of the following option correctly execute without error? मेरे भाई, we have already discussed. This is the node class. How we can create object of this class? Correct, sir. Just write here. Just write here. What's our class name and pass here this data part 10, right? And this is the you are creating the object of this class. So this one is correct, right? You have to pass here na data. So this is wrong, student. This is wrong syntax. This is wrong syntax. So A is a correct, student. Which of the following below option correctly execute without error? A is the right answer for this question. Bache, you forget these things. This is the node class. What is the meaning of this one? So node 10. Node 1 equals to node 10. So this is creating the object of this class. So correctly it work. Creating the object of this class and node 1 is pointing to this class. Self is pointing to this class, right? So A is the right answer for this question, student. Okay. Okay. After discuss the operation on linked list, let take 10 minutes break बच्चे 10 मिनट का break ले ले. Meet 11:35 45 50 11:50 बोल देते हैं. Okay. Meet 11:50 बच्चे. ओके, पानी वानी पी लीजिए. 10 मिनट बाद मिलते हैं. अभी जाना नहीं है कहीं आपको. ब्रेक है 10 मिनट का ओनली. Okay, come back. आ गए आप लोग? सिद्धू, उद्धव? Okay, you are back. Very good. So now, bache, next we are going to discuss the single linked list operation, right? Single linked list implementation with all operations, just like insertion, deletion, search, delete, display, reverse, loop, find, detect, loop, right? So like that, detect middle of the linked list, right? Insert nth node from the ending, merge of two linked lists, like this. So first operation we'll discuss insert at the beginning. I want to insert at beginning in this single linked list. Then how we can insert a student? So this is a linked list. I want to insert at the beginning. Then first of all, what you have to do is, student, first of all, you have to allocate memory for a node, right? You have to allocate memory for a node, right? And this is the data part. And here, this is the next part. This is the data part and next part. Okay. Data part and next part. So first of all, allocate memory for a node, student. Okay. And assign data here. Let I assign data is E. And the next part automatically, this is none, automatically assign none. And the address of this is 500. And let I'm taking new node. So first of all, allocate memory for a node. Now, sir, I want to insert at beginning. Then what you have to do? New node dot next, bache. This is a new node. New node dot next is pointing to what? This node. I want to insert at beginning, na? Insert at the beginning. So new node dot next equals to self dot head. New node dot next equals to self dot head. Okay. Then sir, new dot next equals to self dot head kitna hai? Sir, this is 100. So this is pointing to this one. Okay. This is pointing to this one. And self dot head equals to what? Sir, new node. Self dot head equals to new node. Self dot head equals to new node. Self dot head equals to new node. New node is 500. So this is cut it, and this one is pointing to this one. Okay. So in this way, you can insert at beginning in single linked list, student. And how we can write function for this, student? So right here, def is a keyword to define function, bache. Insert at beginning. Insert at beginning. Self data. Define insert at beginning, self data, function name. First of all, allocate memory for a node. How we can allocate memory for node, student? So right here, node class. Sir, how we can create object of node class? Right here, node class name, and pass here data, and pass here data, student, right? Pass here data. When you write this line, then object object of this node class is created and memory allocated, and you assign this one in new node, like this. When you write this line, then this node is created and new node is pointing to this node. Okay. And new node dot next, then write this line number 1 and after this line number 2. New node dot next equals to self dot head. New node dot next equals to self dot head, and self dot head equals to new node. Self dot head equals to new node. Okay. So first of all, allocate memory for this new node, and new node dot next equals to self dot head. So this one is pointing to this one, and self dot head equals to new node. So in this way, you can insert at beginning. Okay. So what is the time complexity of this student? Sir, what is the time complexity of this one? Sir, this function, is there any loop here? No. So the time complexity is what, sir? Constant. Okay. Is there any loop? No, sir. There is no loop. So the time constant operation, 3, 4 constant operation. So the time complexity is order of 1. So in this way, you can insert at beginning. Okay. Now, sir, insert at the end. How we can insert at the end, student? Okay. Attendance लग गई आपकी आज की. Insert and end. बच्चे code is not important, but you know how we can write code. So insert and end. How we can insert and end, student? So first of all, create allocate memory for a node. Sir, just this is a node, student, and the data part, initialize data part. So data part is data E, and the next part is none. Let the address of this is 500, and new node is pointing to this one. This one. Okay. So if you want to insert at last, then you have to traverse the linked list, bache. Because in a single linked list, standard single linked list have only one pointer, that is head pointer. You have head pointer and you want to insert at last, so you have to traverse this entire linked list. If you traverse this entire linked list, then the time complexity is what? Number of node, order of n. Okay, student. Understood. So how we can write code for this, student? Define insert at end. Self data. First of all, allocate memory for new node, student. How we can create memory? The new node equals to node class. Right here, name of node class and data here. So in this way, this is created, new node is created, and new node is pointing to this memory location. Okay. And check if self.head is empty तो नहीं है कहीं बच्चे. So first of all check, sir, self.head. Head is none तो नहीं है कहीं. Head is none. If head is none, then this is the first node, right? If not, self.head. You can write like this, or you can write like this, student, or you can write self.head is none. You can write like this, or you can write like this, right? It's no problem at all. If self.head is none, then this condition is true, and right here code. If self.head is none, it means what? This node become the first node. Then self.head equals to what, sir? New node. Then self.head equals to new node and return. Self.head equals to new node and return. Sir, new node, and this one is pointing to this one. and written here. Okay. Else if this is false, then linked list is exist. If this condition is false, it means what? Ki linked list have more than one number of node student. Matlab linked list have some node. Then take one pointer last equals to self dot head. If this condition is false, it means what student? Linked list contain some node student. So you have to insert this node at last. Then take last pointer last equals to self dot head. Last is a pointer and self dot head is what, sir? 100. So this one is pointing to 100 and traverse the entire linked list, right? Traverse this entire linked list while last dot next if this condition is true, if last dot next is not equals to none, then this condition is true. You enter the while loop and traverse the last node, traverse last equals to last dot next. Sir, what is the meaning of this one, student? Sir, last dot next is not none, na? Yes, last dot next is not none. Then last equals to last connects. Last equals to last connects is what, sir? 200. So then this is a loop. Again, go to this loop and check last dot next not equals to none. Yes, 300 hai. So last equals to last connects. Ye, sir, this is 300. Okay, this one is pointing to this one. And again, go to this while loop. Last dot next not equals to none. Yes, this and last equals to last dot next. So it will be 400. Condition true. So this is pointing to this one. Okay. And again, last dot next not equals to none. No, sir. Last dot next is none. So you are set at the last node. You come at this last node. Now you have to insert just at the end, student. Then what is the logic for this insertion? Last dot next equals to new node. Last dot next equals to new node. So this is the code. In this way, you can write code in Python, student. Okay. So last dot next equals to new node. The last dot not new node is what, sir? 500. So this one is pointing to this one. And what is the time complexity for this, student? This is basically traversal. So that this is traversal. So that iski time complexity order of n. What is pointer adjustment? Iski order of 1 constant. So total, if we talk about total equals to what, sir? Order of n. Okay. Similarly, bache, insert at a specific position. Insert at a specific position. You want to insert at a specific position. How we can insert, student? So try yourself, bache, specific position, right? बच्चे कर लेंगे या मैं बताऊं? क्योंकि कोड लिखने के लिए नहीं आएगा आपको. ओके, कोड को समझ में आना चाहिए आपको, राइट? सो दिस इज होमवर्क. ट्राई योरसेल्फ. Now delete from the beginning. I want to delete from beginning, student. So how we can delete? So check self dot head is not empty. Then self dot head equals to self dot head connect. Very simple, sir. If self dot head is not equals to empty, then self dot head equals to self dot head connect. Okay. अगर self dot head not empty है, then self dot head equals to self dot head का next. So first you have to check condition, बच्चे. Okay. So define delete from beginning. Delete from beginning. In this way, no need to create memory, student, because you are deleting, not allocating memory, right? Not inserting. So first check self dot head is not empty or not. Student, let's suppose this condition is true. Then what is the meaning of this? इफ दिस कंडीशन इज ट्रू देन इसका क्या मतलब है? यस बोलो. इफ दिस कंडीशन इज ट्रू, if not self dot head this is true, then what is the meaning of this? Yes, student. Yes, if this linked list, if self dot head is none, इसका मतलब क्या है? दिस कंडीशन ट्रू कब होगी? जब सेल्फ डॉट, अगर लिंक लिस्ट एम्प्टी है. इफ दिस कंडीशन इज ट्रू देन व्हाट इज, सर लिंक लिस्ट इज एम्प्टी, then you cannot insert, this is the empty linked list. Understood? Print list is empty and return. Print list is empty and return. List is empty and return here. Okay. If this condition is false, then just write this line, nothing else is doing. Self dot head equals to self dot head equals to self dot head dot next. Okay. So क्या होगा? Sir, linked list is not empty. Self dot head equals to self dot head connects. Sir, this is 200. So this connection is टूट गया. बच्चे ये इसको पॉइंट करने लगा. Python garbage collector, there is no reference, automatically delete this node. So you are pointing this node. Okay. So in this way you can delete from beginning. So what is the time complexity for this? Is there any loop here? No, there is no loop. All 4 5 constant operation बच्चे. Sir, 4 5 constant operation. The time complexity for this is what, sir? Order of constant, order of 1. Now delete from end के लिए you have to traverse the linked list बच्चे. Delete from end, you have to traverse the linked list. So no need to allocate memory. No need to allocate memory. Delete from end के लिए you have to set one pointer at this place. Like the one pointer, the pointer name is second last node. Set one pointer at second last node. You have to traverse from beginning head to up to previous node of this last node, right? And change the second last node next part equals to none, and this node is automatically deleted. Okay. Delete from end. डियर स्टूडेंट, फर्स्ट चेक लिंक लिस्ट एम्प्टी तो नहीं है कहीं. पहले ये चेक करो. इफ लिंक लिस्ट इज एम्प्टी देन रिटर्न. लिंक लिस्ट इज एम्प्टी देन रिटर्न. चेक करिए लिंक लिस्ट में एक ही नोड तो नहीं है. अंडरस्टूड व्हाट आई एम सेइंग? आई एम सेइंग कि सर if head is none, it means linked list is empty, you cannot delete. Second scenario, sir, if linked list contain single node only, if linked list contains single node, sir, in this case just return delete and print message linked list is empty, you cannot delete and return. But in this case, sir, in this case what you have to do? In this case, sir, assign head में sir क्या assign कर दीजिए? None. This node is deleted, student. Okay. So ये आपको काम करना है. So first check this condition बच्चे. First check this condition. If not self dot head, if not self dot head, any linked list is empty. It means there is no linked list. So linked list, no node in the linked list. List is empty. List is empty and return from here. List is empty, return here. Now check another condition. If list contains single node, if self dot head dot next agar none hai, it means linked list contain what, sir? Single node. If self dot head dot next is none, then linked list contain single node. In this case, assign self dot head equals to what, sir? None. In this case, assign self dot head equals to none, student. Self dot head equals to none and return. And return. Apart from this, linked list contain more n number of nodes. Then what you have to do? You have to traverse the linked list, student. In this case, you have to traverse the linked list. So take one pointer name is second last node. And this is self dot head. Self dot head. Okay. While second last dot next is not none, while second last node dot next is not none, right? It means you can traverse in forward direction, right? Second last node equals to second last dot next. So initially, bache, second last node contain what? Sir, initially this contain, sir, 100. And check here, second last dot next, second last dot next is 300. This is not none. Yes, so this is moving one step forward in direction. You come at this place, right? Now again go to this while loop, again go to this while loop and again check, sir, second last dot next is not none. Sir, second last dot next is next 400, not none. Yes, condition true hai. So second last equals to second last dot next. So this is 300. So this is pointing to this one. Now second last node, again check, bache, again check, second last dot next is not none. No, sir, this is none. Second, this is none. Second last 300, next is 400, 400 next is none. This is none. Condition false. बाहर आ जाएंगे. So second last is pointing to what? Sub previous node. Second last is pointing to second last node, right? Or इसका previous node. Okay. Now you can easily delete node. Second last dot next equals to none कर दीजिए. This is none. So this is deleted, student. All right. So in this way, you can delete from the last in single linked list. So what is the time complexity for this one? This is a loop, student, order of 1. This is a pointer adjustment constant. So overall order of n. Okay. The time complexity, this is what, sir? Order of n. Similarly, bache, deleting a specific node by value, try yourself homework. Okay. Now search for a node. I want to search for a node. This is very simple, student. Search for a node. You want to search for a node. Very simple, sir. Define search function. self or key the element that you want to search, right? Key, and take temp equals to self dot key. Take temp is a temporary variable and take self dot head. So temp is pointing to what? Self dot head 100. Okay. And check with all lists while temp is not equals to none. While temp is not equals to none, if temp का data equals to key, temp dot data equals to key, कि temp का data equals to key. अगर ये equals to key है, suppose you want to search sir B, you want to search B, मान लेते हैं sir key equals to not B, I'm saying C, I'm taking C student. So key equals to, I want to search C. So temp equals to self dot head, while temp is what sir? 100. This is not none, condition true. If temp ka data equals to key hai, no, temp ka data is A and key is C. This condition is false. If this condition is false, right, then temp equals to temp ka next. Then temp equals to temp connects. Yes, temp connects is what sir? 200. So temp is pointing to this one, right? Again go to this is while loop student. Again check temp is not none. Yes, temp ka data equals to key hai. No, temp ka data is sir B and key is C. Both is not equal. Then temp equals to temp connects. Temp equals to temp connects equals to what sir? 300. Next again sir temp ka data again check temp. Temp is not none. Yes, temp is not none. Temp ka data equals to key hai. Yes sir, temp ka data equals to key hai. Return data or true or false. So return here what? You can return here true or anything, right? If after this entire loop, this entire loop, if the key is not available, then return what sir? False. So this is the code for searching. What is the time complexity? In the worst case scenario, you are scanning whole list student. The worst case scenario, it is order of n. Okay. So you are applying linear search. In linear search, the time complexity is what sir? Order of 1. Order of n. Order of n, not 1, but order of n. Okay. Yes, student. Now, if I talk about reverse the linked list, I want to reverse this entire linked list, then what you have to do, student? Take 3 pointer, bache. In which take 3 pointer. Yes, Sidhu. Order of 1 best case, order of n in the worst case. On an average case, if I talk about on an average case, it will be order of n because of linear search, right? So reverse the linked list. I want to reverse this linked list. What is the time complexity for this, student? And how we can reverse? What is the logic behind this, student? बच्चे रिवर्स के केस में वेरी सिंपल सर टेक 3 पॉइंटर प्रीवियस करंट और नेक्स्ट, राइट? प्रीवियस करंट और नेक्स्ट. प्रीवियस में क्या लीजिए सर? नन लीजिए. प्रीवियस में नन लीजिए सर. करंट नोड को पॉइंट कर रहा है एंड नेक्स्ट नोड को पॉइंट कर रहा है, राइट? और यस टेक 3 पॉइंटर्स एंड मूव अहेड. सर इस प्रीवियस असाइन करिए सर. इनिशियली प्रीवियस में क्या है सर? नन, राइट? इनिशियली प्रीवियस में क्या है? नन. एंड करंट को आगे बढ़ा दीजिए सर. प्रीवियस में फिर पहले प्रीवियस में करंट एंड करंट इक्वल्स टू करंट का नेक्स्ट. ओके, इस तरह से बच्चे फिर इसमें आपको क्या असाइन करना है? प्रीवियस इसको पॉइंट कर रहा होगा. इसमें प्रीवियस यानी इसमें इसका एड्रेस डाल दीजिए सर 100. सो दिस नोड इज पॉइंटिंग टू दिस वन. अंडरस्टूड? सिमिलरली आगे मूव करिए सर. इसमें इस नोड का एड्रेस डाल दीजिए. सो दिस इज पॉइंटिंग टू दिस वन. एंड सिमिलरली सर इसमें इस नोड का एड्रेस डाल दीजिए सर 300. सो दिस वन इज पॉइंटिंग टू दिस वन. और इसको रिटर्न करा दीजिए. ये आपका हेड बन जाएगा. रिटर्न दिस नोड. ओके, So sir, complexity क्या होगी बच्चे? You have to traverse entire linked list, right student? You have to reverse entire linked list, not display. You have to reverse entire linked list. So time complexity is order of n. Understood? Define reverse. The function name is reverse and take self. Self is a parameter and previous, take one pointer, previous equals to none. Previous equals to none and current equals to self dot head. Current equals to self dot head बच्चे. Okay. Then what will happen? Previous equals to none. Initially, sir, previous equals to none. And one more pointer, current equals to self dot head means what, sir? 100. So this one is pointing to this one. And check while current is not none. While current is not none. Current जब तक not none हो, right? Current node. Next node equals to current dot next. Next under node equals to current dot next. So one more pointer. Current dot next. What is current dot next? Is 200. Okay, so this is pointing to this one. And current dot next equals to क्या कर दो? Previous. Current dot next equals to previous student. Current dot next equals to previous. What is inside in the previous student? Previous is what, sir? None. So this is none. Okay, if this is none, so this is not pointing to this one. Okay. Current dot next equals to previous and previous equals to current. Now move ahead, sir. And previous equals to current. Previous equals to current. Sir, what is current? Is 100. So this one is pointing to this one. Okay. And current equals to next node. And current equals to next node is what, sir? 200. So this one is pointing to this one. So this connection is disconnected. All right, student. So now in the next scenario, this is removed. Okay. Sir, after this, you go to this while loop. Next iteration, for next iteration, current not equals to none, bache. Current is 200. Yes, current is not none. So next node equals to current dot next. Next node equals to current dot next is 300. So this one is pointing to this one. This connection is break, student. So this connection is removed. Fine. And current dot next equals to previous. Sir, current dot next equals to previous. What is previous? Sir, 100. So this is pointing to this one. So this connection is break here. Okay. And previous equals to current. Sir, previous equals to current is what, sir? 200. And sir, current equals to next node. Next node is what, sir? Sir, 300. Right, student? Again, go to this while loop and check again one more iteration. Current is not none. Yes, sir. Current is 300. This is not none. So next node equals to what, sir? Current dot next. Current dot next is what, sir? 400. So this is 400, right? And next node equals to current dot next. And current dot next equals to previous. Current dot next equals to what, sir? Previous. Okay. ये चेंज हो गया था बच्चे, ये इसको पॉइंट करने लगा था. Current dot next equals to previous. What is previous? Previous is 200. So this is pointing to this one. So this is pointing to this one. This connection is break. Okay. Now previous equals to current हो जाए. Sir, previous equals to current. What is current? 300. And current equals to next node. Next node is what, sir? 400. So this one is pointing to this one. After this is pointing to this one. Okay. And previous 300 हो गया बच्चे. Previous इसको point करने लगा. Previous equals to 300. After this again go to here. Current is not none. Yes, current is 400. This is not none. Next node equals to current dot next. Next node equals to current dot next. Current dot next is what, sir? Current dot next equals to what? Current is 400. Next part is what, sir? None. So this is none. Okay, fine. Now current dot next equals to previous. So current is what, sir? 400. Next is previous. Previous is what, sir? 300. So here 300. So this one is pointing to this one. All right. And previous equals to current. Previous equals to current. What is current, sir? Current is 400. And current equals to current connects. Current equals to current connects equals to what, sir? None. After this, you again go to this while loop. Current is none. Condition false. आप बाहर निकल जाएंगे. You exit from here. Now self dot head equals to what? Self dot head में क्या आना चाहिए बच्चे? इस node का address. Who is pointing to this node, student? Sir, the previous is pointing to this node. Previous is pointing to this node. So self dot head equals to previous. Self dot head equals to previous. Okay. So yes, in this way, if you just pull this linked list, reverse this entire linked list. And what is the time complexity? Here you are using this loop. So the time complexity for this is what, is student? Order of n. Or we can say theta of n. Okay. So this is the answer. Now finding the length of the linked list, very simple, sir. You can try yourself, bache. You can try yourself. Now next, display the linked list. Sir, very simple. Try yourself, bache. Okay. Now next is find the middle node of the linked list. I want to find the middle node of the linked list. How we can find middle node of the linked list, student? So middle node, sir, if we have only single node, so this is the middle node, you can return the address of this node. Okay. If we have two node, then you can say this is the middle node, right? Or you can say this one. So if you write this node, then it's a little bit difference in logic, student, right? So if odd number of node, then exactly you're saying this is the middle node. If even number of node and written this is the middle node. If odd number of node, this is the middle node. Write code for this, student. I want to find the middle node of the linked list, then write code for this, student. My dear student, this is Mr. A and B. Okay. Understood, student. The speed of Mr. X is twice x and speed of B is x, right? If both is moving to this one, who come first at the end position, student? कौन पहले पहुंचेगा? इनकी स्पीड ट्वाइस एक्स है एक्स से, कौन पहले बच्चे डेस्टिनेशन इस पे पहुंचेगा? बोलो भाई. ए पहले डेस्टिनेशन पे पहुंचेगा या बी? दोनों में रेस हो रही है, कौन पहले पहुंचेगा बच्चे? सर ए पहले पहुंच जाएगा, तो बी कहाँ होगा सर? एग्जैक्ट मिडिल। सर बी कहाँ होगा? एग्जैक्ट मिडिल पे। रिटर्न दिस वन, दिस इज द मिडिल नोड स्टूडेंट, दिस इज द मिडिल नोड। ओके, so you know the concept of slow pointer and fast pointer. Take two pointers, slow pointer and but one is slow pointer, another is fast pointer. Okay. Yes. In this approach you can easily find sir, sir दो लोगों में सर फास्ट पॉइंटर है डबल स्पीड से आगे बढ़े, सर स्लो पॉइंटर सिंगल स्पीड से आगे बढ़े, तो फास्ट जब लास्ट पे होगा तो स्लो कहाँ होगा? मिडिल नोड पे होगा। रिटर्न, उसके एड्रेस रिटर्न कर दीजिए। अंडरस्टूड? फाइंड मिडिल नोड, मिडिल नोड नाम middle node of the linked list self. If not self dot head, if self dot head is none बच्चे, so if self dot head is none, it means linked list is empty. Return none, return none. In this case, return none because there is no middle, because linked list is empty, student. Okay. Otherwise, if this condition is false, then take two pointer, slow equals to self dot head. Take another pointer, fast equals to self dot head. Slow equals to self dot head and fast equals to self dot head. Okay. And fast equals to self dot head. Both is pointing to same position. Okay, now check while fast and fast connects not equals to none. While fast and fast dot next is not equals to none. Fast and fast dot next. Sir, why I'm writing this condition, student? For safe movement, right? For safe movement हम पहले देख रहे हैं कि गड्ढा तो नहीं है, गिर तो नहीं जाएंगे उसमें, राइट? ये कंडीशन किसकी लिखी है? हम आगे चेक कर रहे हैं गड्ढा तो नहीं है उसमें, गिर तो नहीं जाएंगे, कहीं ऐसा तो नहीं नन एरर आ जैसा डी नन पॉइंटर आप डी रेफरेंस करें बच्चे। while fast and fast dot next is not none, then slow equals to slow का next and fast equals to fast dot next. Okay. So yes sir, fast is what sir? Fast is 100 and fast connects is 200, not none. So slow equals to slow connects. तो स्लो आगे बढ़ा, स्लो इस पे आ गया बच्चे, एंड फास्ट इक्वल्स टू फास्ट कनेक्ट, फास्ट इस पे आ गया, राइट? नाउ आफ्टर दिस अगेन गो टू दिस while loop and check condition. Fast not equals to none. Slow is what sir? Slow is 200 and fast is what sir? Fast is 300. Okay, after this sir, slow is pointing to this one and fast is pointing to this one. Now next time check fast is 300 and fast connects क्या है सर? 400. आप आगे जा सकते हो, गड्ढा नहीं है सर, नन पॉइंटर डी रेफरेंस नहीं होगा। मूव स्लो इक्वल्स टू स्लो कनेक्ट्स, तो स्लो इक्वल्स टू स्लो कनेक्ट्स, स्लो इसको पॉइंट करने लगेगा बच्चे। स्लो किसको पॉइंट करेगा सर? 300 को, तो स्लो इज 300 एंड फास्ट इक्वल्स टू फास्ट के नेक्स्ट कनेक्ट्स, फास्ट के नेक्स्ट कनेक्ट्स क्या होगा सर? फास्ट इस पे आ जाएगा, फास्ट इस पे आ जाएगा बच्चे। ओके, सो फाइनली आप इस तरह से मूव करेंगे तो ये फास्ट इस पे पहुंच गया। ओके this one, Now again go to this while loop, fast and fast connects. Sir, fast is not none, yes 500, and fast connects is not none, no it is none. अब आगे जाओगे तो एरर आ जाएगी बच्चे, सेफ मूवमेंट नहीं है, तो आप एग्जिट हो जाएंगे, इसी while loop से एग्जिट हो जाएंगे। और देखिए फास्ट लास्ट पे पहुंच गया है, तो सर फास्ट लास्ट पे है, देन वेयर इज स्लो पॉइंटर बच्चे, वेयर इज स्लो पॉइंटर? If fast is last, where is slow pointer, student? Exact, sir, middle. This is middle node, right? So return slow pointer, return slow data. Slow dot data, what you want, or pointer. Slow dot data or pointer. Return middle node data. It return middle node data. What is the time complexity? In this case, you have to traverse this loop, sir. In single scan, sir, you have to traverse this loop. So the time complexity is order of n. But in single scan, you can scan this entire linked list. Okay. Detecting cycle we'll discuss tomorrow, and now I want to discuss binary search here, student. Do you know what is the concept of binary search, student? Do you know what is the concept of binary search, बच्चे? Okay. Sir, I want to find the middle node of this linked list. Can I apply binary search? This list is sorted, student. This entire list is sorted. Can I apply binary search, student? Can I apply binary search on linked list, or we cannot apply binary search on a linked list? Yes, student. Can I apply binary search on a linked list, or we cannot apply binary search on a linked list? The necessary condition for binary search is list must be sorted, student. Linked list must be sorted. Linked list must be sorted. Definitely you can apply binary search, sir, no problem at all. But the necessary condition list should be sorted. Okay. So in binary search में first find middle node. In binary search बच्चे first find what, sir? Middle node. Sir, first find, sir, what, sir? Middle node. First find middle node. And what is the time complexity for middle node? We have just seen, बच्चे, this is the time complexity for finding the middle node, right? So find the middle node, right? This is the middle node, and check this middle node. The key you want to search is check with this middle node. If key is less than this middle node, then search in the left half. If key is greater than 1, then search on the right half. Okay, search on the right hop. If there are total n elements, total n node or n element in the linked list, then how many node in the left hand side, student? How many node in the left hand side, bache? Sir, near about, sir, n by 2, and here, sir, n by 2. Okay. Now, the binary search, if n number of node, the time complexity for this search is Tn. Let I assume for n number of node, this is Tn. So Tn equals to what, student? Tn equals to what? If n equals to 1, if n equals to 1, then directly you can search, right? The time complexity is what, sir? Constant. This is the base condition of recursion. If n greater than 1, bache, if n greater than 1, then what will happen? First you search middle. First you search middle. Yes, the cost for, first you find middle node. If more than n number of node, then first you have to find the middle node. And what is the time complexity for finding the middle node, bache? This is the time complexity. So this time required, okay. ये टाइम लगेगा सर n for middle and search for this node, student, search for this middle node, the time +1. And sir, if element not middle node, then you can search recursively either left side or right side, but not in both direction. If key is greater than 4, then search on the right hand half. If key is less than 4, search in the left hand part, right? So you can search either left half or right half. How many number of node in the left half or right half, sir? N by 2. For n element, sir, this is Tn. For n by 2 element is what, sir? T of n by 2, either in the left half or in the right half, bache. So you can consider only one, either left side or in the right side. Don't consider both. Okay. So Tn equals to sir, Tn by 2 plus n. So 1 is a constant. For simplification for easy calculation, remove it. So this is the recurrence relation, bache. This is the recurrence relation for binary search in linked list, single linked list, student. If you solve this recurrence relation, what you will get? You will get order of n, bache. If you solve this recurrence relation, then time complexity is what, sir? Order of n. Then time complexity is order of n, bache. So my dear student, linked list per, if you apply linear search or if you apply binary search, then linear search cost is also order of n and binary search cost is also order of n. No benefit, student. No benefit. If we apply on array, linear search is order of n and binary search is order of log n. Okay, so conclusion of the story, sir, if you apply, sir, linked list per binary search apply करेंगे. If you are apply binary search on a linked list, then there is no improvement. It is just like a linear search. Linear search is order of n, binary search is also order of n, sir. But binary search code is complex code. It is a recursive code. It take resources of the system, right? Stack space. This is very complicated. Overhead cost इसमें add होगी, right? तो जो चीज़ आपको, वही चीज़ आपको कम दाम में मिल रही, ज़्यादा में मिल रही, तो आप क्या लेंगे, सर? Understood? You prefer this. In this case, prefer this. Don't prefer this, right? Understood what I am saying? I am saying कि आप लिंक लिस्ट पर बाइनरी सर्च लगा सकते हो, नो प्रॉब्लम, बट कोई फायदा नहीं है बच्चे, कोई इंप्रूवमेंट नहीं है. इसलिए कहा जाता है कि लिंक लिस्ट पर बाइनरी सर्च नहीं लगाते हैं. इसका मतलब ये नहीं है कि आप नहीं लगा सकते हैं, राइट? अंडरस्टूड? You can apply binary search on a linked list, but there is no benefit, right? Order of n time. It is just like linear search, but linear search is simple as compared to binary search, right? Binary search take extra stack spaces, right? दिस इज अ रिकर्सिव कोड, वेरी कॉम्प्लिकेटेड कोड. सो इन दिस केस प्रेफर दिस बच्चे, प्रेफर लिंक लिस्ट पर प्रेफर देखिए. वेयर इज इन एरे, एरे में लीनियर सर्च इज ऑर्डर ऑफ एन, राइट, एंड बाइनरी सर्च इज व्हाट सर, ऑर्डर ऑफ लॉग एन. सो इस केस में इसका परफॉर्मेंस अच्छा है इन केस ऑफ एरे. सो एरे पे हम बाइनरी सर्च लगा सकते हैं, बट द नेसेसरी कंडीशन फॉर बाइनरी सर्च, एरे शुड बी सॉर्टेड स्टूडेंट, और लिंक लिस्ट शुड बी सॉर्टेड, देन यू कैन अप्लाई, अदरवाइज यू कैन नॉट अप्लाई बाइनरी सर्च. अंडरस्टूड? सो बच्चे दैट्स ऑल इन टुडे क्लास. बच्चे कल की क्लास में मिलते हैं. दैट्स ऑल इन टुडे क्लास. Tomorrow we will complete linked list, and we will solve some PYQ also, and some important question also regarding in linked list, right? Tomorrow in linked list, entire linked list finished, student. Okay. And the day after tomorrow we will start after linked list stack data structure. Okay. Okay बच्चे, thank you so much. Bye bye, take care, see you again. भैया लेक्चर अपने दोस्तों को शेयर करिए, ये काफ़ी बेनिफिशियल लेक्चर है, अपने फ्रेंड्स को शेयर करिए.